Hello. Okay, good morning again, everyone. So sorry for being late. I've been ordering Uber for more than half an hour, but seems no one want to pick me up. And so this term we have two different courses combined together. So that's why we have two different QR code for you to take the time attendance. And okay, so let's firstly give you a course overview. Mhm. Yeah. So as I've just mentioned, this term we have courses from Comp S492 and Comp 3920. So there's like two different courses. The first one is 5 credit, and the second one is 3 credit. So my name is Hong Li, and I'll be your instructor this semester. And yeah, so here are my contacts. So if you have any questions, please feel free to contact me through email, WhatsApp, or WeChat, as you prefer. And yeah, so actually I'm not local, as you may mention. So I mean, I'm from mainland and not actually in Guangdong. I'm from Zhejiang, so it's actually quite far away from here. And the point here is that I'm not able to speak Cantonese. Sorry for that. Like, I've tried to learn about that, but for me, I mean, you should trust me that Cantonese for me is more difficult than machine learning. So if you can speak Cantonese, I believe that you can study this course quite well, because I think machine learning is easier. And yeah, here's my office location, but I think you don't have time to come to meet me. And here's some information for the teaching mode. So as you may know, we have every week lecture at Thursday, 9 a.m. to 11 a.m. So yeah, early morning, but I don't like this schedule. And in total, we have 5 lab sessions. So yeah, most of you might already take part in the labs. Yeah, so you might already meet your tutors. So for people from the course comp 3920, I think it belongs to P01 and 02. Your tutors are Alex Chen and Stephen Tai. And I will be in charge of the lab P21. So tomorrow morning, again, in the early morning. Yeah, hope I will not be late again tomorrow. And the other tutor is Yu Zhizhou. So I think you've already met him. Like he's in charge of P22 and P23. So for the course material, I'll update on the OLE every week before the lecture or before the labs. Yeah, so please always check the update information and the announcement in the course page. And so actually I've created a WhatsApp group. I don't know if you already know that, but let me show you. Slideshow. Here you can find on the OLE. Yeah, for students from both courses, you can find the WhatsApp QR code here. You can just scan to join the WhatsApp group. And I know the purpose of this WhatsApp group is that I know that some of you might not check regularly your email and the OLE system. So if I have any information to update to you, I will post in WhatsApp group as well. Yeah, so that's it. But still, I will post the informations in 3 different channels: the OLE, the email, and the WhatsApp group. If you are afraid of missing something, please just also check your email regularly, because maybe there are some information sent by the university. Okay, and then actually let me talk about assessment first, that you might be interested. So this semester, we have a little modification on the syllabus. Previously, we have OCAS 30%, OES 70%, but this time we have half and half. So in total, you have like 10 assignments for each lab. I think 9 of the assignments are from the lab, and one of them I plan to put a tutorial talking about some maybe mathematical things that you might met in the exams. And also you have a midterm exam, which takes 20% of the overall score. That will be a 1-hour exam. It will take place in the lecture room, I think. I don't know. Yeah, maybe I need to book another room, but it's fine. So it will take place on 13th March. Yeah, just please take a note here. And in the end, you will have a mini project, which will take 20% of your overall score. And this mini project, you can find your partner, but the maximum number of team members is 2. And you can always do it alone, but it depends on you. So please be careful when you are finding your partner. If you already start the project and you told me that your partner is not working, I cannot do anything, because it's hard to check if he's working or not. So yeah, so if you are afraid that you find a partner that only depends on you, then maybe you can work alone. For the students from the course comp S492, because your course is a 5-credit course, so you might have some extra tasks in this project. But don't need to worry, it will be not a difficult extra task. Probably I will just ask you to take a video, and take a video for you to introduce your project, like what's your idea, what the methodology you use, and what's the result. Could be like 5 minutes or to 10 minutes long, I think. So that's it. And OES will take 50%, so it's quite important. It will be a face-to-face final exam, 2 hours. Yeah, and please notice here that the midterm exam and the final exam are all closed book. And another important thing is that you must pass both OCAS and OES to pass this course. I think you've already be familiar with these requirements. So even you have got a very good score in the OCAS, you still need to take part in the OES and pass the OES. Yeah, then let's talk about the learning outcomes. So this course is machine learning, and we will mainly focus on the conventional machine learning. And what I mean is that you might know that machine learning also include deep learning, like neural networks. But the main content of this course is the conventional machine learning, which is based on statistics. And yeah, so I think there is an arrangement problem of the course that they arrange on the 3rd year and 4th year, but it's decided by the university. But later, I mean, for new students, we might have some change. This course should be a bit earlier. And yeah, we are also going to talk about deep learning in the end of this course. Some of you might be interested, but we don't have quite a lot of time to talk about that. And so upon the completion of this course, at least you will be able to identify and explain the common machine learning algorithms. And also, you need to design and implement various machine learning algorithms in a range of real-world applications. So you may know that different machine learning algorithms might fit different kinds of applications in different scenarios. So after that, after this course, you know in what kind of tasks you should choose what kind of machine learning method or model. And also you will learn how to perform evaluation of learning algorithms and model selection. So actually these are the same things, because once you know how to evaluate a model, then of course you know how to select a model, depend on the evaluation result. And yeah, in the end, you also need to be able to explain the capability and the strengths of and the limitation of various machine learning techniques. So that's need a bit deeper understanding of the machine learning models for you to understand their strengths and the limitations. So I mean, after you've known all the models, then you just need to compare them to see the strengths and the limitations for each of them. And yeah, this we've already talked. So I mean, yeah, like all other courses, we have textbooks here, but it's not necessary for you uh, to read or get them, because all the content is actually already contained in the lecture notes and the tutorials. So don't need to worry. But if you're really interested in these books, you can take a look. So any questions regarding the overview of this course? Okay, if no, then let's move on to the first chapter, the introduction to the machine learning. Okay, so let me talk a bit about the content today. So firstly, we'll learn like how machine learns. And then we will learn about like the characteristics of machine learning models. Also, we'll talk about the relationship between AI and machine learning. And also the pros and cons, the advantage and disadvantage of using machine learning. And in the end, I will give you an overview of the machine learning workflow for you to understand how you deal with a machine learning task. So at the beginning, how machine learns. So let's first explore a crucial concept in machine learning. So that is memorization and true intelligence. So let's take a binary classification task as an example. So as you may know, classification is one of the most significant tasks you might meet through all the courses and also your whole career in machine learning. And binary classification means that in the classification task, you only have two categories. So that means binary, because there are only two categories, 0 or 1. That's why it's called binary. And let's start with image some examples on the left. So this image represents a training data set where the machine learning model is taught to distinguish between the cat and the dog based on the provided examples. So it learned to associate certain features like the fur texture, facial structure, or even the background. And so the machine learning model use these kind of features to classify an image if it's a dog or a cat. And so the left side, we call it training examples. And when we test the model, we use unseen examples as shown in the right side. So these images present the data that the model has never seen during the training period. And a key question here is that how well the model can generalize, or in other words, how well it can perform on the unseen examples. So a model rely on memorization might struggle with unseen cases, especially if they have unique features. Like here is a cast on the cat's leg, and or the pug here has some distinctive appearance compared with a normal dog, a general dog. So if the machine learning model only learns other dogs without ever seeing pugs here, because the appearance of pug and dog is very different. So it might be difficult for machine learning model to recognize a pug here. And on the other hand, a model with true intelligence, it has a deeper understanding of the pattern. It would identify the key characteristics of cats and dogs regardless of the new variations. So this highlights the challenge in the machine learning. So we should ensure that the model don't simply memorize the training data, but instead we should develop the ability of the model to generalize to new unseen situations. So that is true intelligence instead of just memorize the features from the training set. And this distinction is fundamental in applications like image recognition, voice processing, or autonomous driving, where encountering unfamiliar scenario is inevitable. And as we continue, we will discuss techniques to to ensure the model can be generalized to unseen samples instead of just memorize the features. Then let's talk about the difference between how human learns and how machine learns. So human learning is actually more sophisticated. This means humans are very good at understanding new situations and applying what they've learned to the new things they've never seen before. For example, if you know what a dog looks like, then you can recognize a new type of dog, even it looks like a bit different. But machines are better at memorizing, recalling, and processing huge amount of data. Machine can analyze millions of pictures of piece of information much faster than humans, but they often struggle to deal with new situations they haven't trained before. So, the machine learning model is highly dependent on the training data. And both humans and machines share one important ability, that is the generalization. So it means to use what they've learned in new situations. For humans, it comes naturally, but for machines, it's still a big challenge. So here we have example. Wait a minute. There's Let's try something interesting. So here is a quick draw like this developed by Google, I think. And so it's like you draw something and the machine learning model will try to understand what you are drawing. So it's like, to give you some example. Okay, so what is that? I think you can skip it. Okay. Yeah, so for example, it asks us to draw a door. Okay, much easier one. So we just draw a door here.
line. Or skyscraper. Or square. Oh, I know. A store.
Yeah, you see. Or also my drawing, or although my drawing is very bad, but he can still understand. Like a banana.
I see nose. Or spoon. Oh, I know. It's banana.
Yeah, although it looks like shit. But for example, a table.
I see line. Or tent. Oh, I know. It's table.
Okay, this is more challenge. Try again.
I see bread. Or cloud. Or foot. Or crocodile. Or bear. I see snake. Or garden hose.
You
Oh,
see?
I know. It's dragon.
Yeah, much better understanding than human, right? What is smell? Okay, I don't know. Smile. You mean smile?
I see canoe. Or boomerang.
Sorry, let me check this word. Smile.
I couldn't guess it.
Hectares. Hectares. I know if you know this word, but
I see name.
that's why we
Or
can
street light.
have a competition
Or
compared with the
skyscraper.
machine.
Or finger. I see hat. Or toilet. Or saxophone. Oh, I know. It's cactus.
Yeah. Okay. Sorry, this one looks like a bit forbidden. Okay, but okay, no problem. Yeah, so if you're interested, you can also have a try in your leisure time. So this address you can find in the PPT that I will upload in the OLE later. Okay, so what I want to say here is that if you give enough training samples for the machine, then it can learn very well, even the things are very abstract. So actually, you might don't understand how the machine can understand these kind of abstract things. This is because it is keep continuously learning. That I'll talk about it later. Yeah. And so it's like one participant draws something, and the new samples will be given to the machine learning model, and then the machine learning model will learn to recognize based on this new picture you send it. And then gradually when more people participate, and then they all show their own drawings, because humans usually have some common sense on the drawing of these kind of things. So machine learning model is able to recognize these kind of patterns. Yeah, because most people have similar drawing ability, but maybe a bit better than me. Okay, so then let's start. Keep talking about the next things. Yeah, okay. So then let's compare machine learning to classical programming. So in classical programming, you use rules or logic to create by, use or logic created by humans. For example, let's see the diagram here. We take data and apply the rules written in the software and get a result. For example, a traditional program might calculate your final score of, your final score of this course based on a formula and the input of your OCAS and OES score. And it calculates the final score of this course. However, machine learning works differently. It learns patterns from data instead of relying on fixed rules. So let's say in the example here, we firstly give the machine examples. This is the data the machine has already seen, like pictures of cat or dogs. And the machine used these examples to build a model, which is like, which acts like its brain. And once the model is ready, we can give a new data that it has never seen before, and it predict the results, such as whether a new picture is a dog or cat. So the key idea here is that machine learning uses data in the past to predict the future. So it learns by finding patterns in the examples we provided and then generalize that knowledge to new unseen data. This is why machine learning is powerful. It doesn't require us to define all the rules. It discovers the rule of the underlying signals or data by himself, making it perfect for tasks whose underlying patterns are difficult to be defined by humans. Yeah. Oh, sorry. Then let's talk about how machine learning model works to recognize cats and dog. Today we'll still, at the beginning, we'll stick on the cats and dog. So let's break it down step by step. Firstly, at top left, we have labeled training data. So these are images of dogs and cats that we show the model during the training, and each image comes with a label. Like here's a dog, so it's labeled as dog, and here's a cat, it labels as cat. Then the machines can learn the patterns that define each categories. And this is also called supervised machine learning. So this we'll talk later. So it's like if you have both input data and labels of the data, then it means supervised because you need human to manually put the labels of the data. And then in the middle here, we see the machine learning process. The model takes the label examples and learns the key features of the cats and dogs that we've already talked about, like the fur texture, the shapes, the colors. At this step, we have trained a model which is ready to be tested here. Yeah. And then we have unlabeled test data here. These are new images that models has never seen before. The goal is for the model to correctly identify whether this image are dog or cats. So this is called the recall process, where the model applies what it learned during the training to label the new data. Yeah, so please notice here that the test data should be unlabeled. And then we see the test results here. The model correctly identifies most of the images, but it makes mistake on the cat with a cast because kind of some things block his leg, and it labels it as a dog. So it means the machine learning model made a mistake here. So it means like the model are not perfect. They sometimes struggle with unusual or complex examples. Okay, then here are some common types of problems that supervised machine learning can solve. Let's start with classification. Yes, I've already mentioned that it's the most common tasks in the real world. And the goal of classification is to decide which category something belongs to based on the input data. For example, like the spam filtering and the fraud detection, customer advertisement targeting. And the next one is regression. So regression, sometimes we also call it prediction. So it's like we predict a number or value instead of a category. For example, regression can help with stock market prediction and estimate our prices. I'm sorry. I mean the prices of the stock every hour. And also, for example, it can predict the house price, I mean, every year, something like this. And also like weather forecast. Yeah, weather forecast can be either classification or regression. For example, if you are forecasting tomorrow's temperature, then it will be regression because it's a number. And if it's like you are predicting it's sunny or rainy, then it is like classification because it don't have a real number. Instead, it has some categories. Okay, then the third type is recommendation. So this is about predicting like what someone might prefer. It's like you are doing shopping in some online platform, then you may, every time you may say something on the button that they recommend something to you. So this is recommendation. This is also realized by machine learning. And yeah, the last one is imputation, but usually, I mean, it's not very common. Or yeah, it's just like infer value of missing input data. Actually, I think it's also kind of regression. So it doesn't matter. It's like to apply to the incomplete patient medical records or the missing customer data. But yeah, I think it's very similar with regression. Okay, but all the things here we talked about are all supervised machine learning, that we have labels and the input. Then let me give you one more example of using machine learning in something like a loan application. So, you know, like previously, every time if you want to apply a loan, I mean, you need to provide your information, personal informations, and then there will be some other guys evaluate if you are qualified to apply a loan. And then it will take a very long time. The process will be very long. So it's not efficient. So that's why later we use machine learning method here. So it will be something like a binary classification task. You give the machine learning model your personal informations, and then like in not even 1 second, they can decide if you are qualified for applying loan or not. So this, I mean, dramatically increase the speed of this process. So you don't need to go to the bank or something where fill up the forms and waiting for several weeks. You can just go online and then check it online. Just need to click the mouse to get the feedback. Okay, then let's see how this machine learning is applied to this process. So firstly, we have labeled training data. And so this training data has all your info, I mean, not yours, I mean, some information in the history that people are applying for the Lawrence. They have all their personal informations. And then you supervise the machine learning model. So you put the label that if a certain guy get the application or not. So when you have a large number of this kind of information, then you can train the machine learning to see what are the most important features considered for the application. And once the machine learning model learns the underlying patterns of those applications, you can just give your new applications from new people to it. And then, according to the criterion created by the machine learning model itself, it will predict if this application will be approved or should be approved or not. Yeah. So this is the point, one example. And then let's talk about the characteristics of machine learning model. So firstly, let's talk about the types of machine learning models. Yeah, as I've talked, we have supervised, unsupervised, and reinforcement learning. Yeah, so I think 90% of the tasks you might met in the future will be supervised machine learning. So it means you'll give labels. So it takes some human effort. And actually doing labeling is one of the big tasks nowadays, especially for image recognition. And yeah, so for supervised machine learning, we have classification, regression, and things we've already talked about. And these are some example algorithms that we might learn later. And then let's talk about the unsupervised machine learning. So yeah, the only difference with supervised machine learning is that you don't need to give label to the data. So because it doesn't have any label, it cannot predict exactly what it is. So what unsupervised machine learning doing is usually doing clustering. So it put the data with similar patterns together into a cluster. Yeah, so it's like, I had to give an example. Let me think about it. Yeah, so yeah, here's an example, but maybe a bit offensive. So like according to your score, so of course it did not depend on the clustering, but it's quite similar with when we decide your final score. Like you are A or B or C or D, depends on your final score. Depend on the grade. And so nowadays we usually use threshold method because it's a very simple problem. We don't need to use machine learning algorithm to cluster it. But if it's more complicated, for example, it consider more different dimensions, not only your scores, but also like your, of course it's not, but like, for example, if it consider also your gender, your height, and your family, these kind of things, then you cannot only set a threshold to cluster different grades. Then you need to use machine learning method because there are too many features for the input. And this is very similar with clustering. And also there's something called dimensionality reduction. So this is like, as I've talked, like sometimes your input data might have a lot of features, and some information might be redundant, and you don't know which feature is important. Yeah, like for example, if we are single here, then you might think about your future partner, and then you will have some criterion, like maybe he should be handsome or she should be beautiful, and how high he should be. These are something like the features of the person. And then you evaluate. I mean, sometimes you might not able to find your dream guy or girl, and you might do some reduction of the things you want. And this is actually very similar with dimensional reduction. So the machine learning model need to know which feature or which characteristics is more important in some tasks. And this also unsupervised learning. And then the next category is reinforcement learning. So this one is like planning. So like when you are using your Google Map, then it give you a track to some different places. So it depends on reinforcement learning. And also nowadays a very hot topic is the autonomous driving. And it also depends on the reinforcement learning to give the best way to go for the car. And also, of course, it also needs some supervised learning because you need to train the car to recognize the the field or the scenario in front of the car if there's a people or there a car or it's empty. So this is based on supervised machine learning. It's just like computer vision, image recognition. But when you got all this information and fuse them together, you should give a final decision where to go. You stop, you go, or you speed up. Then this is more about reinforcement learning. And yeah, anyhow, we are going to talk about all these kind of machine learning models, so don't worry. And okay, so let's start step by step. Let's talk about model training first. So this is an essential step in the machine learning. And machine learning is the process of teaching a machine learning model how to make predictions. So during this step, the model adjusts its internal settings or parameters to find the best way to solve the problem. So actually, the model is just trained to develop a function to map the input to the output in the best way. And to train the model, we use training data. So yeah, so like all the examples I give you on the left in the previous things, it's called training data. So the data set, that's a data set with examples that have the correct answers. So the model uses the data to learn which features are more important and how to combine them to make accurate predictions. Yeah, so one important thing here is that the examples should have correct answers. So if you are training a model, you must give the model with examples with correct answers. If you give with wrong answers, then of course the prediction performance will be bad in the future. And always data is the most important part of machine learning model. So we see that data decide the lower limitation of the machine learning model, and the algorithm decide the highest performance. I mean, yeah, so data is the most important part. I'm not sure if I explain in the right way. So it's like 数据决定了机器学习的下限，但是算法决定了机器学习的上限，所以下限还是比较重要的。And so during this step, okay, sometimes we don't just train one model. We train several models together and compare their performance. And after that, we choose the best model. Yeah, this is what we talk about for the training step. So you can try different models to get the best one for a task. Okay, after training a machine model, the next step is model testing, to test the model. And this is all the things we also mentioned before. In the dog and cat examples, we give unlabeled dog. If you still remember the pugs and the cat with cast on his leg. And this is where we check how well the model performs. So to do this, we use test data. Wait a minute, I forgot where we use test data, right? Yeah. And unlike training data, test data is unseen by the model. it hasn't been used during the training. So it helps us measure how well the model can generalize its learning to new data. So the goal of machine learning model test is to ensure the model is accurate and reliable. So through the test, we can know if the model, the training data provided is enough or not. So if the performance is very bad, then you can input more data to help the machine learning model to increase its performance. And also, you can see from the test if the structure of the model is suitable for this problem. If the machine learning model you choose is suitable in this scenario. And testing give us confidence give us the confidence that the model can work well in real world situations where it will encounter data that it hasn't seen before. So if the model doesn't perform well, then we may need to adjust the training process, the data, or even you need to change a model. Okay, then now let's have a maybe 10 minutes break. And yeah, we'll keep talking about this machine learning later after 10 minutes. So you can have a break now. Thank you very much. And also, yeah, so if you forgot to take attendance, then you can keep doing that. Okay, so I have uploaded the PowerPoint to the, for this lecture to the OLE. If you would have a look, you can just download it now. Okay, let's keep going the model performance. We just talk about testing, yeah, and performance. Yeah, so after we test the model, then we know the model performance. So we should know that if we provide the model with examples that are clear, distinctive, and present the real-world data well, then model will perform better, and poor quality data can confuse the model and reduce the accuracy. So please remember, data are always the most important part in the machine learning. So when you are doing machine learning tasks, the first step when you are processing the data, it is very important. So if you haven't processed the data well, then no matter how well your algorithm or your hyperparameters, no matter how well are done, the result will not be good. So also, secondly, it is important to know that the performance can vary. So a model can perform poorly during training, testing, and real-world use. This means the model hasn't learned the pattern well. And also, the model might perform very well during the training, but poorly during the test or the real-world use. So this happens when the model has memorized the training data instead of learning the patterns. It doesn't generalize well to the new real-world data. So it is also called overfitting, and later we'll learn about it. And actually, the first case here is called underfitting. So the model is not powerful enough to get the pattern from the data. It means underfitting. But overfitting means it learned too much from the details of the data. Yeah, so this topic we'll talk about it later. And then let's talk about continuous training. So which is a way to keep machine learning model updated while they are being used. So yeah, this is the thing that I've mentioned when I was joining on the Google Draw. Yeah, so it means when some new data update to the model, it will be used to train the model again to improve the performance of the model. So the point here is that sometimes the data you got for a specific task are very limited. You don't have enough data to get a very good performance for the model. So you may want your model to keep learning from the new data after it has been deployed. And it is also called online learning or continuous training. So actually in our daily life, there are quite a lot of examples. For example, your smartphone, like your Face ID, learns from your face over time when you unlock your phone to better understand you. Because sometimes you may wear glasses for, in different situations. And sometimes you may wear masks. And also for girls, you may have different level of makeup every day. Sometimes you might don't want to do makeup, and sometimes you may, face some important situation, and then you will do some makeup. and this will change, your feature, the feature of your face, and maybe increase the difficulty of the model to recognize you. Yeah, but I think nowadays the models are quite advanced, so it's not a problem. It may depend on your something like your eyes or other things. And also like the keyboard input. So it learns the words you use often to improve its prediction. And for example, you put like in the keyboard of your cell phone that dialing, then maybe it will pop up something like I love you or I hate you, something like this. And might be if you usually cue your boyfriend, then when you type his name, it may pop up something like blah blah blah, I want to cue you, something like this, right? Yeah. So there are also some online tests that ask you to type several words and to see what it pops up in your keyboard to check your characteristics or your kind of situations, but yeah. And also like for personal assistants like Siri, it gets smarter as they interact with more people, more users. And so here is a diagram of the continuous learning, shows how the continuous learning or online learning, continuous training, sorry, works. So as the new data come inside, you will have a result. And here, actually, I think there's something called confidence. So if the confidence is very high, then okay, the result will probably be true. So it will use the result and the data to create a new example for the model and train it to learn from the new data. Yeah, this is because you might have some questions that the data, the prediction is not always correct. So what happened if you use wrong data to continuously train the model? So I think the mechanism here is that there's some kind of parameter related to the confidence of the model. And when the confidence of the model is very high, it will use the data and the result as a new example for the input to train the model. Yeah, then let's talk about the relationship between machine learning and artificial intelligence. So here we have a diagram here. So you know that we have artificial intelligence, machine learning, and deep learning. So start with the largest circle here. Artificial intelligence, or we say AI, refers to any techniques that enable machines to mimic human intelligence. So it can include things like recognizing speech, solving problems, or playing chess. AI doesn't always involve learning, so it could be used some hard-coded rules or some logic to achieve intelligent behavior. And the things I've mentioned here, like playing chess, is actually also reinforcement learning that we are going to talk about later. And then inside AI, we have this machine learning. So machine learning uses statistical method to enable machines to learn from data for prediction or decisions. And for example, like spam email filters using machine learning method to recognize patterns of the spam messages. And yeah, and we also have deep learning here. So the main difference between machine learning and deep learning is that machine learning based on statistical method, but deep learning is based on neural networks. So why it is called deep learning is because at the beginning, people use a lot of layers of neural networks to increase the performance. But yeah, there's also some small neural networks with only 2 or 3 layers. But sometimes you may have questions that why there are only three layers and you still call it deep learning. But yeah, it's just a common, they just call it deep learning, but I prefer to call it neural network. And actually, I think there is some standard to see if something is a deep learning. I think it should be over 3 layers, then you can say deep learning. Yep. Okay, then never mind. It's okay. You just need to consider it as the deep learning. I don't want to confuse you here, but yeah, later you may, after you have some deep understanding of these things, you might know the underlying things behind them. And okay, then let's talk about the one thing that, yeah. So I forgot one thing. The reinforcement learning is actually also a part of machine learning. Yeah, but the mechanism of reinforcement is actually very different with deep learning and some classification method that we are going to introduce. They are quite different actually. Okay, then let's talk about the pros and cons. I mean, the advantage and disadvantage of machine learning. So firstly, machine learning uses data to find the best solution to a problem. So it learns pattern from data, helping it to make decisions that are often more accurate than human. For example, machine learning powers the medical diagnosed tool that can detect disease like cancer in scan with high accuracy. It also helps predict loan defaults in finance by analyzing the credit history that we've just talked about in the previous example. And also machine learning is faster, so it can process data and give answers in milliseconds. This is great for real-time applications. And also machine learning can be tailored to solve many types of problems. So it is more customized. You just need to provide data and then the machine learning model can learn by himself. So if you ask, you want to, I mean, if you're human yourself, want to create some logic or some functions by yourself for some customized problems, then it will be very difficult. But machine learning, you just need to provide data and then it can learn the things by himself. And also machine learning is more scalable. For example, as your business or data grows, machine learning scales with it. So it can handle huge amount of data without slowing down and making it ideal for growing systems. For example, social media platform like Facebook or Instagrams, they use machine learning to analyze billions of posts, likes, and comments from the users every day, and ensuring your feed remains relevant to you. Yeah, that is scalable, that you can use the machine learning model to with a lot of data. Okay, then let's talk about some key challenges we face when we're working with machine learning. So these challenges often occur before we even start training the model, and it can significantly impact its performance. Yep, so the first one is data preparation. In the real world, the data sets are often messy. For example, we can see the table here, and you can notice that there's some missing values. Like the outlook here is missing and the humidity is missing. So these missing values are usually encoded as blank or some placeholders like NaN. Yeah, I think you've seen before. That means not a number, NaN. And if we don't handle these missing values, we can confuse the model and the accuracy of the model will be reduced. I mean, the performance of the model will be reduced. And data preparation also involves cleaning and transforming data to make it usable. For example, we may need to convert text data into numerical values. So like the ChatGPT we are using these days, so your input is text and how the machine can understand your text. because you know that machine can only understand numbers like 0 or 1. So the technique they used here is called word embedding. And then they embed each word according to their relevance in a vector space. And so they put more relevant things together in the vector space. For example, like maybe cat and dog, they are more closer because they are all animals. And then like cat and chair, they might be further, because it belongs to different things. And then the model is able to predict what you want depend on the relevance of the word vectors. So this is how this ChatGPT work. Yeah, and talk about ChatGPT, you might know that it's named as pre-trained generative transformer. Yeah, generative pre-trained transformer. So like transformer is a model proposed in 2019, I think. And then it speed up the AI process because it's a very powerful model. But you will not learn this in this class because it's quite complicated. But I guess you might use it in your final project, maybe. Okay, then. Yeah, the second part is the problem formulation. So we need to define the problem clearly. So the problem means like you should know that your task belongs to like classification or regression or other things. So if you want to predict someone, let's say here, if you want to predict someone is going to play, for example, tennis or not in this kind of weather, then it means classification. But if you want to predict how long this guy will play under these weathers, then it means regression. So if you are using classification models to solve regression problem, of course, you'll get very bad results. And yeah, so the third challenge is to choose a suitable algorithm. Yeah, that actually I've already talked about. And after we've processed the data and figure out the problem formulation, we should know that the strengths and the weakness of each model. Then we can choose the model that fit the problem best. So we can see that, like, for example, conventional machine learning method like LDA or SVM that we might learn later, but some of you might already know. So they might need less computational power, but they might not able to feed the data well in some complicated scenarios. So of course, for example, if the ChatGPT, you are using this kind of conventional machine learning method, then of course it will never work because those methods are too simple and it's not able to summarize the underlying patterns of the applications. And for example, neural network can handle complex problem like transformer, but it requires large amount of data and it might be easily overfitting. Yeah, so this is like, for neural network, usually you need to prepare a large amount of data, and because it's more powerful, it has much more parameters inside compared with conventional machine learning method. But if the data you provided is not enough, then the neural network will overfit to the data you provided. So this is also another problem you might meet in the future. And also something like key means clustering, like the clustering problem we've just talked. So it uses unsupervised learning. It works well to group similar data, but it struggles if the data doesn't naturally form clusters. And selecting an algorithm isn't just about performance. It also depends on factors like the size of the data size, the resources available, and how explainable the result need to be. For example, in the healthcare application, we might prefer simpler and more interpretable models like logistic regression over complex ones like deep learning to ensure the doctors can trust the decisions. Because as you may know, like neural network, I mean, deep learning is not explainable. So it's like a black box. You give the input and it gives you the output. You never know what happened inside the neural network and why it performed like this. So this means it is not explainable. And okay, then let's have a look on the workflow of the machine learning task. Yeah, the first step is collecting and preparing the data. This is the foundation of any machine learning project. So we get the data from various sources such as historical record, database, or your own sensors. And then we need to clean it. As I've just talked in the previous steps, you need to clean it to ensure its accuracy and then ready to use. So this might involve handling missing values, like the previous example I've showed you, and also removing duplicate values or converting data into format that's suitable for modeling. Yes, and I want to mention again here, data is the most important part. Without a good data, even the best algorithm will fail. And then the second step is to build the model. In this step, we choose a machine learning algorithm based on the problem we are trying to solve, like classification, regression, or clustering, and train it to use the prepared data. During this process, the model learns the underlying patterns from the data to make decision later. And after we build up a model, we need to do evaluation. So this is done using test data. We've already talked about it for many times, which the model hasn't seen before. So we have measure metrics such as accuracy, precision, recall rate, and like mean squared errors depending on the type of problems. I don't know if you've heard about this kind of terminology, but it's okay. We will learn about it later. And yeah, for example, in the previous example, we've discussed about the low-end, I mean, the application of the low-end. We should use the accuracy to see how many predictions are correct and how many predictions are incorrect to see if the model helps to make these predictions and then to decide if we apply this machine learning model in the real world. Yeah. So after we evaluate the model, so we know the performance of the model, then the thing we need to do is to optimize the model. We always want the model to be better to get a good score. Yeah. So here is one thing I want to mention, that for your final project, the mini project, the score, it depends on the performance of your model. So probably I will give you some classification tasks, and your score of the project will depend on the accuracy of your model. And I will give you training set and test set for you to develop the model. But in the end, I will use another data set that I will not provide to you to test your model. So the thing you need to do is to ensure that your model can generalize to new data, unseen data. Yeah. So yeah, let me explain it again in Chinese. So 你们那个最后的那个 ，sorry, I think 你们最后的那个作业就是那个项目 project，最后的那个 mini project，我到时候评分的时候是按照你们那个模型的训练，就是那个训练效果来评分的。就是比方说，我会给你一个，比方说分类的任务，然后我会提供你2个数据集，有一个数据集呢，你可以用来 训练这个模型，然后另一个测试集你可以用来测试你的模型。然后你要做的事情就是让它尽可能的可以 generalize 到不同的数据，就即使这些数据呢你那个模型之前没有见过，但是它仍旧可以提供一些比较精准的分类，提供比较精准的分类。然后最后呢，我自己还会有一个数据集，然后我会用自己的数据集去测试你的模型，就防止你把那个测试集去用来训练，然后做作弊这种事情。所以我会自己再准备一个数据集，然后我会用你的模型在我自己的数据集上跑来测试你这个模型最终的效果，然后根据你这个模型最终的效果，我会那个按照那个你的accuracy 就是那个精确度来给你一个最终的打分。Yeah, I don't know, like when I change English to Chinese, I think my Chinese is getting worse. I don't know why. Okay, so what we were talking about? Yeah, we just talked about optimizing the model performance. Yeah, and that is the prediction on new data. So yeah, this is what I've talked about in the project. So training, test, and then predict on the new data. So once the model is optimized and performed well, that means it's ready to make predictions on new data. This is where the real world application happens. Also, it is how your the score of your final project decided. So for example, a trained model can analyze new customer data to predict whether they will buy a product, or even like something like detect fraud transaction in real time, or forecast tomorrow's weather. These are the application of the models. Okay, then let's have some look at the, Let's have some look at some examples. Like I've give you some data here. And what data is about? Yeah, let's say this data is about we want to predict a person's marital status. So if it is single or married. And we have some features here. So this is typical data we have. And for all your tasks, your data will also be something like this, like a table. And you have some instance. So this means an example, like person one. And then this person will have some features here. Okay, so you should say here, each column represents for a feature, and each row represents for an example. And yeah, this is a kind of typical way that you should structure your data. And then how we build a model. So let's say we have in total 1, 2, 3, 4, 4 features here. Yeah, this person is not a feature, okay? Yeah, please do not use person here as a feature in your project, because this is user's information. And it's a kind of leakage, so it will increase the difficulty of your model. Okay, so let's say we have features, name, age, and income. And then we put last column as the target. So this is the column that the data we want to predict. And we give the model input, the name, age, and income to train the model. And also, because it's supervised learning, we also provide the model with a target value. And what the model is doing is that it will create a function that maps these features to the final target. And once you get enough data, this function will be good enough to predict the target. And then when we, I forgot a bit, okay, sorry. Using model for prediction, yeah. And then after we build the data, after build the model, then we will use some new data to input to the model to see the output. So for example, we have some new person here, Trent and Lily, okay? So Trent is a young boy with low income. And Lily is a old girl with very high income, and so you just put these kind of informations to the machine learning model, and then it will predict if it will be single or married. This is how you use the model, but how you evaluate the model. So it's like for your test data, you already know the true target of each person, like the marital status of each person. You already know. But when you do the test, you're not going to show the model these target values. Instead, you just put these three features to the model, and then the model will give a prediction if this single or married. After that, you compare the prediction of your model with the true labels that we have to evaluate if the model is correct or not. So because here we only have two examples. And yes, luckily the model find out the true label for each person. That the Trent is single and the Lily is married. Yeah. This is we call evaluation. And this is example in the classification task. So it's about accuracy of the classification. Yeah, and then let's talk about how to optimize the model performance. So it's about to improve the accuracy, efficiency, and the reliability of the machine learning model. So the first way is to tune the model parameters. Or we say optimizing, to optimize the model parameter. And many machine learning models have parameters called hyperparameters that control how the model learns. For example, in a decision tree, the depth of a tree is a hyperparameter. And in the neural network, the learning rate, the number of neurons, and the layers are all hyperparameter that you can you can change, modify them to get better results. Yeah, so I think, so for conventional machine learning method, actually for each model, there are not a lot of hyperparameters for you to define, to tune, but in neural network, you will have a lot of parameters, especially when you are using a very complex structure in your network, then you will have a lot of hyperparameters to tune. And also, I think this will be your main job in your career if you would like to work on machine learning later. So because, like only if you are an expert in machine learning and neural network, or you are doing master or PhD, then you might create new architecture of model, or you combine different models or method together to give some novelties to increase your performance. But in industry, I think because all the things are very mature already, so usually what you need to do is to decide the parameter of a model, of a given model. And you don't need to create your own models because, it's like billions of people working on that. Of course, they already have very good models being deployed in different applications. But what you need to do is just to fine tune those parameters in the model. But yeah, but it's a very tough job. It takes a very long time for you to do these kind of things, even if you want to do like PhD or even your final project, final project of your bachelor, not this course. You might need to tune a lot of parameters to give your model a very good performance. And it will take a long time to compare it with different parameters. Yeah, because each parameter you have quite a lot of possibilities. It can be 1, 2, 3, 4, 5. And let's say if you have 3 parameters, and then you test like 10 different kind of parameters for each hyperparameter, then the combination is already 1,000 for only three hyperparameters. Yeah, this is what I want to say. It's like exponential growing when the hyperparameters, the number of hyperparameters grows. Okay. Yeah, and also there are other ways to optimize the performance, like feature selection. That's actually we've already talked about when we are talking about dimension reduction. And it can help reduce the complexity of the model while improve the performance. So for example, in a data set predicting like house price, so it will be something like the location and the size of the house might be very important. And if like something like the inside paint color might add little value and it may introduce noise. So when you are training the model, you might better to delete these kind of useless features and keep those important features. And reducing the number of features also speed up the model, making it more efficient. Yeah, so actually we've already talked about, we've mentioned a bit about the PCA, Principal Component Analysis, to help identify and remove irrelevant redundant features in the previous slides, but it doesn't matter. I think we'll talk about it later. And okay, the third way is pre-processing the data to ensure it's clean and consistent. Okay, so it includes scaling. So scaling ensures all features are on the same scale. So usually we use standardization or normalization. And also we have encoding, which convert categorical data into numerical format, like one-hot encoding. I don't know if you know about one-hot encoding, but let me give you a small example. For example, here we have marital status, and you see we have single and married. And these words are very difficult for the machine to understand because machine have no idea about what is single, what is married. So the easiest way is that we put single as 0 and married as 1. So this is called one-hot encoding. And when the categories increase, we just need to increase the number of 0 and 1. For example, if we have let's say we have three status, single, married, or gay. Then maybe single can be 0, 0, married can be 1, 1, and gay can be 0, 1. Yeah. You know what I'm implying. And yeah, I hope you didn't misunderstand. Okay. So, and okay, what we are talking about. Pre-processing the data. Yeah, this is encoding. So after that, there are some, just on time. There are some common terminologies in this class then that we can have a review. So like these are also other things that you might meet later in your courses, like instant and example. So instance actually means example. So it's a single object, observation, or yeah, these two you don't need to think about. So it is a single observation or a single example of the data. So let's say here a person, the trend mostly is an example. So it's a training data, it's an instance. And target or label. Yeah, so when we are doing machine learning, the output means the target, or we say the label. So supervised machine learning, we always need a label for each input. So the label is the things that you want to predict. And also here are features. So okay, the features are the input attributes that are used to predict the target. These are also, this also may be numerical or categorical. Yeah, but doesn't matter. I mean, usually it can be numerical. Oh, no. Yeah, even it is categorical, you can encode it with one hot encoding. So in the end, it will be numerical. So it doesn't matter. And the model is a mathematical object describing the relationship between the features and the target. So this is the main part that we train. So actually, we are just training a mathematical object, map the input, map the features to the labels. This is the model. And training data is the set of instance or example with a known target to be used to train the model. And test data is the things with unknown target. I mean, it's the target is not given to the machine learning model, but you know it. So you use the testing data to test the model. And supervised machine learning means you have some labeled output, and unsupervised machine learning means you don't give any labeled data. And this machine learning workflow we've already talked about. Okay, so what time is it? Yeah. So it's the end of this class. Thank you very much for your time and see you next week.